Look up at the sky. For as long as humanity has existed, we've been captivated by the stars. Tiny specks of light in a vast and unfathomable universe. They represent so much more than just distant points of fire. They are beacons of possibility, exploration, and dreams. For millennia, we have wondered what it would be like to harness their power, to capture the energy that radiates from them in a continuous flow. What if we could do that? Not just capture, but control the power of a star, the very source of life itself. This is the essence of the Dyson sphere, an artificial megastructure that surrounds a star, capable of harnessing its infinite energy for the benefit of an advanced civilization. Imagine a civilization so advanced, so daring, that it could build something this massive. A Dyson sphere, or its cousin, the Dyson swarm, would represent the apex of technological achievement, a testament to human ingenuity and ambition. But it also raises a monumental question. Could we, as humans, ever have the capability to construct such a thing? The Dyson sphere isn't a recent idea. It was conceived by the brilliant physicist Freeman Dyson in 1960, a man whose mind bridged the gap between the known and the unknown. Dyson wasn't thinking of a single, solid sphere encasing a star. That's a popular but inaccurate interpretation. Instead, he proposed a Dyson swarm, an interconnected network of solar-collecting satellites orbiting a star, each working in harmony to collect the star's energy. If such a structure were built, it would allow us to tap into nearly limitless power. In fact, a Dyson swarm could collect energy on a scale that far exceeds any current energy generation system we know. This energy could potentially fuel entire cities, industries, and even space exploration. It could power our future in ways that we can only dream of now, enabling us to leave Earth behind and venture out into the stars. But even though the idea of a Dyson sphere sounds fascinating, the real challenge is how to turn it into a reality. What would it take, in terms of technology, materials, and time, to create a structure that could surround a star? The idea of a Dyson sphere challenges the very limits of human ambition. Imagine a world in which humanity has unlocked the potential of the stars themselves, transforming entire industries and opening up new frontiers of exploration. Energy would no longer be a barrier to our survival. With enough power to fuel space exploration, we could colonize other planets, develop technologies we cannot even begin to understand today, and create sustainable habitats in distant parts of our galaxy. But as grand as this vision is, it requires an understanding of not just the possibilities, but the immense challenges ahead. The scale alone is almost unfathomable. To build even a basic Dyson swarm, we would need an incredible amount of materials, not just on Earth, but from other planets, moons, and even asteroids. After all, the volume of material needed for such a megastructure far surpasses anything humanity has ever built. And then there's the technology. Current space construction methods, as impressive as they are pale shadows of what would be necessary. We would need advanced robotics, space-based manufacturing facilities, and new propulsion technologies to transport and assemble billions of satellites in orbit. Here on Earth, we are already pushing the limits of our energy production. Fossil fuels are running out, and renewable energy sources, while promising, are still far from meeting the global demand. We face an energy crisis, with billions of people requiring more and more power every year. A Dyson sphere could eliminate this problem forever. However, it's not just about gathering materials or engineering satellites. We would need to build entire space-based factories, robotic assembly lines operating in the cold vacuum of space, capable of assembling these satellites far from Earth's atmosphere. These satellites would need to be lightweight and durable, and they would need to operate under extreme conditions, constant exposure to solar radiation, extreme temperatures, and the constant threat of space debris. We would also need new methods of energy transmission, beaming energy from these satellites back to Earth. This could be done through lasers or microwave beams, but developing the technology to transmit power across such distances without loss would be an extraordinary challenge. To gather the materials needed for a Dyson swarm, we'd need to look beyond Earth. The asteroid belt, which lies between Mars and Jupiter, could hold the key to unlocking the construction of such a megastructure. This region of space is teeming with metal-rich asteroids, many of which contain the very materials that would be necessary to build our satellite network. Resources that are simply unavailable on Earth in the quantities we'd need. We could send mining missions to these asteroids, mining materials for the creation of solar panels, structural supports, and propulsion systems for the satellites. We might even build space-based factories that operate independently of Earth's gravity, assembling the components directly in orbit. This space-based construction would require breakthroughs in robotics, AI, and autonomous machinery. The satellites themselves would need to be precisely calibrated to withstand the harsh conditions of space, while also ensuring that the entire structure operates as a cohesive unit. A single failure in the system could cripple the entire Dyson swarm, leaving us with nothing but debris floating in space. However, with such grand ambition comes an equally immense risk. A Dyson swarm would be an intricate system of satellites, each orbiting at precise distances from one another and the star. But what happens if one satellite malfunctions? What if a small error in the trajectory of one satellite sets off a chain reaction, causing collisions that destroy much of the structure? We could end up with a debris field, not just around Earth, but throughout the entire star system. There's also the issue of space debris, something that we already struggle with today. If we build a Dyson swarm, we must anticipate the risks of collision and the potential for damage to existing satellites. We may even have to develop entire debris removal systems to ensure the Dyson swarm remains intact and functional over millennia. Furthermore, maintenance would be another ongoing challenge. How would we repair a malfunctioning satellite? How could we replace broken or degraded components of such a colossal structure? A Dyson swarm, by its very nature, would require constant monitoring and upkeep to ensure its continued operation. But despite these challenges, the benefits of a Dyson sphere are nothing short of transformative. Imagine a future where clean, infinite energy is available to everyone on Earth, enabling us to eliminate pollution, reverse climate change, and create a sustainable world for future generations. With the power of an entire star at our fingertips, we could finally tackle the greatest challenges of our time, from poverty and disease to space exploration and beyond. A Dyson swarm would provide unprecedented energy for humanity's expansion into space, facilitating the colonization of other planets, the terraforming of Mars, and the establishment of thriving space habitats. It could pave the way for interstellar travel, enabling us to journey to distant stars and explore the universe in ways that are currently beyond our imagination. The Dyson sphere represents more than just a structure. It's a symbol of human potential, a testament to our ability to overcome any obstacle, to reach for the stars, and to solve the problems that stand in our way. In the grand scheme of time, perhaps it is a question we can answer only in centuries to come. But the dream, the vision, is already there. We are already exploring the possibilities, researching new materials, testing new energy technologies, and learning how to build in the vastness of space. The impossible might not be impossible forever. If we keep moving forward, step by step, there's no reason we couldn't eventually build something as awe-inspiring as a Dyson sphere.